Okay, this is part two. Hopefully you've already done this particular problem um, before you started this. If you haven't, pause it now, do the problem, and then come back and see if you got it right. Okay, so based off what we did a while ago, we have a line. We have a line that bisects. You see the two congruent angles. Because it bisects, we now have two congruent sides that are equidistant from the rays. Okay, so we'd set them equal to each other. 2x plus 3 is equal to 4x minus 11. Subtract 2x from both sides. So you end up with 3 is equal to 2x minus 11. Add 11 to both sides. 2x equals 14, so x equals 7. Now it says x equals 7, but again, we are looking for KL, which is this particular side here. Okay, don't want to make it super darker if you can actually notice or not. Alright, so then we'll plug this in, take the 7 and plug it in here. So we have 2, and then insert or substitute our x, plus 3. So we have 2 times 7 is 14, plus 3 is equal to 17. So this equals 17, and because they're actually the same distance, equidistant from each other, that is also going to be 17. So now we have our information down in the bottom instead of actually on the diagram. So it tells us that HI is 7, so we'll start labeling. IJ is 7. That right there is a trigger or a key to let us know that these are equidistant, therefore it's going to do that converse theorem that we talked about. Because these are equidistant here, that means we're going to create two equal angles there. Well, it tells us here that HGI is 25. Well, because of the equidistant and the congruent angles, because they've been bisected, you're going to have IGJ actually is going to be the same as this. Okay, so angle I said IGA, but IGJ is going to be congruent to angle HGI. And we know that HGI is 25 degrees. And since they're congruent, that too is going to be 25 degrees. So 25 degrees is going to be answer for angle IGJ. Alright, so I've cleared it off for the next problem because we're using the exact same diagram for this one as well. HJG is 57 degrees. I see H. Hold on a second, sorry about that. So it says HJG, which is the whole thing, is 57. IGJ, which is this one here, that one's going to be 28.5. Okay, so now we want to know is this a triangle that is the angle that's been bisected? Well, let's check and see if 28.5 plus 28.5, see if that equals 57. Okay, the 1. So then we carry the 1 again. That's for be 57 degrees. So because that this is because this 28.5 plus itself is equal to the 57, then that means that this also is angle is also going to be 28.5, which means it has been bisected. Now that we know that this is bisected, we can now take our theorem that says if you have a bisected angles, two angles that are basically the same here, then that means these two lengths are going to be the same as well. Okay, so it says HI is 12.2. Because HI is 12.2, we know that these are IJ is going to be equidistant because of the bisecting angles, then we know that this one also is going to be 12.2. Remember, this doesn't work if these angles aren't bisected, or these two angles here aren't the same. If they're two different ones, then the theory of, or the theorem of these two won't work. So now the do you understand part. What is the relationship between the segment and its points on its perpendicular bisector? Well, on that first question, basically the segments are bisected, creating equidistant two segments that are bisected will mean they're going to be the same, so they're both going to be equidistant from the bisect. So on the second part of that question, I went ahead and wrote it down for you. Between an angle and the points on its bisector, angle is bisected, creating two congruent angles. How can you determine if a point is equidistant from the sides of an angle? Well, that meant one, the angles are bisected, and it's a perpendicular bisector. So if it's a perpendicular bisector, that means you created two equal angles, and you have an intersection at the bottom of those segments that creates a 90-degree angle. So create a small little diagram saying like if the angles are bisected and creates perpendicular, and it might have cut off a little bit, and I'm trying to move it up and I won't move up any, but that says intersection. And over here to your left, you'll notice you'll have your bisecting angles and then also creating a 90-degree angle, because that's what perpendiculars do. Perpendiculars create 90-degree angles. Okay, River says KM is the bisector of LKJ because LM and MJ are equal. Explain the River's reasoning, or the error in his reasoning. Well, before now, a lot of things we've seen looked almost very similar to this. One thing that they are missing is this here. We don't know for a fact that KM is a perpendicular bisector. Okay? We know that they are equidistant, but we don't know that they're a perpendicular bisector. If they're a perpendicular bisector, then yes, we can go ahead and say that then River, his or her explanation is correct. Okay, but his error in reasoning is we don't know. So we don't know that KM is a perpendicular bisector. That's the reason we cannot say that River's statement is true. Okay, if we had those little boxes meaning 90-degree angles, then yes, we can make that idea or assumption and carry on with what we have been doing. But because that was missing, we can't assume that. Try these next ones, these next three questions on your own. Again, pause, work it out, come back, and I'll put the answers up for you. Okay, on the first one, it gives us all this information. I already went ahead and labeled it. So we're basically looking for JK, which is going to be the same as KL. So they give you all this information, and really we needed to know was, yes, we know this is a perpendicular bisector because, one, it has the 90-degree angle, and the whole thing is 14. So the ML is 7, that makes JL also 7. Because of that, we know that bisects the segment, then these two legs are going to be the same, or these two sides are going to be the same as well. So if KL is 10, so is JK as well. All right, so now we look at the question mark, which we're looking for is YZ. Okay, we have the angle bisectors here. So we know that they're angle bisectors. We also know we have our perpendiculars here. So now we know we have perpendicular bisectors, All right, we have an angle bisector, so we have a perpendicular. That gives us everything we need to know that xy is going to be the same as yz. So xy is going to be equal to or congruent to yz. And because of that, one of them's 4, that makes the other one 4 as well. And that's your answer to that. Okay, so now we have the next problem, which we're dealing with is the second one here. I've got all the things labeled. So we have the two segments here are the same, which they've been almost like equidistant. We also have the 90-degree angles. So because we have the 90-degree angles and we have two equidistant segments, then we know that it's going to be bisecting that angle, and that's dealing with the converse theorem that we talked about a little bit ago, or I talked about a little bit ago. Okay, so these angles are going to be the same. So if YWZ is going to be 18, so then when we look at XWY or XWZ, actually, yeah, it threw me off a little bit. So we know that this is also going to be 18. It's asking for XWZ, which is the whole thing. Okay, so if this one is 18 and the bottom one is 18, put them together, the whole thing is going to be 36 degrees. So XWZ, angle XWZ, is going to be 36. So be careful, pay attention to what you're being asked to do. Always pay attention to the instructions on what you're going to be asked to do. That concludes this. Hope it helps you out, and good luck in your assignment. I'll see you tomorrow.